talking about quadrics in OpenGL. We saw tessellation. Like if I have a convex, if I have a concave shape polygon, means it's not like in OpenGL there is a GL library, so that is OpenGL. So GL library is not capable of drawing shapes in concave polygons. So GLU, that is the OpenGL utility library. So it comes forward and it provides a kind of in between or algorithm which takes the concave polygon as an input and set of convex polygon it gives. But still, means convex polygon is again it is in point, line, triangle or maximum chord. So with that I can draw a polygon or kind of tilted polygon and so on. I can draw linear polygon. What about polynomial? What about quadratic? What about drawing something that is not linear? Like in 2D, like circle, or in 3D, kind of a sphere, cylinder, disc. So these kind of models, they need a kind of quadratic equation. X square, y square, z square, x, y, x, z, y, z, x, y, z with some coefficients. So that is quadratic equation. So if you follow the quadratic equation, then we can have kind of non-linear models, 2D circle and 3D spherical. So we have to now kind of a little bit we have to come forward, kind of we have to leave, and then we come to kind of a simple to polynomial, linear to polynomial, quadratic equation, and with that we can draw kind of little complex models. We can use tessellation on top of it. There is no issue. Okay, so what about ready-made quadratic shapes? So GLU provides using, means we can also do, but on our behalf they provide kind of a few algorithms that draws quadratic shapes like a sphere, cylinder, disc. How it is managed in OpenGL GL? So that comes in a kind of an arena of quadrics. So quadric is an object. Okay, what is object and what is function? So the difference between a function and an object is a kind of a container and which has a set of properties and which has operation. So function is a kind of a part of an object and properties are part of an object. If I combine property and function and club together in a kind of in an abstraction in a group, so that is called object. So quadratic shapes means it takes a kind of a form of object in OpenGL that is called quadrics. So I have algorithm like drawing a sphere and drawing a cylinder or disc through GLU, but how it is managed? So in quadrics, in GLU quadric algorithm, we have quadric object. If it is an object, then certainly the operation is drawing a sphere or drawing a cylinder, drawing a disc, whatever its properties. So if I have a kind of algorithm drawing the sphere and that algorithm, that operation comes under quadric object, so its properties are like if it has lighting capability. So lighting capability, any kind of vertices it can have if it has normal vector. So like in GL begin, GL end primitive. if we kind of set vertices, it draw vertices. But other properties like normal vector, other properties like texture, other properties like color. So anyway, if I provide texture, then it draws the color only. But whatever. So coloring or placing normal or texture. So if I have a quadratic operation like GLU sphere, and that belongs to a quadratic object, quadric object, then its properties will be if it supports lighting, means it also provides normal. If it supports drawing texturing, so it has the textual coordinates, only textual coordinates, only normal. Okay, and what is the kind of its contour? I mean, what it draws? So it draws set of points or lines or polygon. If normal is exterior or interior, means it points outwards or point inwards. I mean, we have so many properties. So if I have a quadratic algorithm drawing sphere, I can also write an equation of drawing a sphere. If I follow the kind of a GLU quadric protocol, then I should support these kind of properties. So if I am writing a kind of algorithm to draw a quadratic shape, then since it is an operation is belonging to an object. So in my function, when I take the other parameter for drawing the shape, I should take a parameter of the quadratic object also. And I can populate its property. Okay, if someone has set the object property as normal, then I have to set GL normal, 3D, 3FB. Or if someone has set enable texturing, then I have to set the texture coordinate also. Okay, so altogether, we'll see that how if we have been provided with GLU quadric algorithms like drawing a sphere cylinder, then how we can manage through GL quadrics. We'll create a GL quadric object. We'll set its properties. I want normal. I want texture enabled. I want normal outwards. I want lines, not points, not polygon, only lines between the vertices. So if object property is set, then that object we can pass to the algorithm, and inside the algorithm, it would kind of populate those textual or normal functions when it kind of draw the vertices. So we see the quadrics in OpenGL, how various quadratic operations are managed through quadric objects, where its properties we can set, and object which property is set by the user is given to the operation, algorithm of drawing the like a sphere, and it does the work. So okay, so we'll proceed on desktop. So this is Linux Mint. Okay, so quadric surfaces are non-linear surfaces, the way we discussed. And quadratic equation, quadrics means it is following a quadratic equation. And it follows a quadratic equation. So it is x square, y square, z square, xy, yz, xz, xyz, and one constant. So this is a kind of a polynomial equation. And for the polynomial equation, if this is of kind of power 2, so This will lead to kind of a circle or sphere in 3D. So quadratic equation, the surfaces, what is drawn. So anyone can draw, means quadratic surface. GLU provides few quadratic surfaces, that is the tessellated approximation of 2D, 3D shapes. So that we'll see. So GLU also leading to these equations, GLU has a few ready-made quadratic equation based surfaces. So how we can draw the surfaces? So that we'll see. Generating these surfaces, someone has to follow the mathematical equation, and then it will go with the tessellation, and finally it will receive the set of vertices and its primitives. I think we have already discussed that. So what is available through GLU, that we'll see. Okay, so we'll also see that if GLU provide quadratic equation based surfaces, then how it can be managed through quadratic objects. So what is quadratic object and what is quadratic shapes? So how they are linked with each other, that we'll see. Okay, so what is OpenGL library and what is OpenGL GLU library? So we are talking about GLU. Okay, we are not talking about GL. So OpenGL is a GL library, OpenGL.gl, that is a Python package. So OpenGL is the package and GL is the sub package. Okay, and it draws convex polygons, and typical primitives are point, line, triangle, quad. And GLU is capable of, means it provides tessellation and it provides quadratic service. It is provided through GLU subpackage. So we'll see. So GLU internally it does the tessellation, and then it comes to a bunch of vertices and normal and texture, color, and once everything is decided, then it finally with primitives, and then those each bunch is finally, it is called again the GL library. So GLU internally calls GL library with convex polygons, simple polygon like point, line, and triangle and quad. But whatsoever, the quadratic surfaces what we are seeing, so those are provided to GLU, and internally it calls GL. So that is the scenario. Okay, so as we discussed, quadratic object is a kind of object like C++ object, Python object. And if there is an object, so there are attributes. If there is an object, there are operations. Like anyway, everything is C API. So if GLU, so like GLU sphere is a kind of a function which draws the sphere. So it has code to draw the sphere vertices, cylinder, disk, and partial disk. If we see, like if there is a quadratic object, then quadratic object is created through a kind of a factory method class, like GLU new quadratic. So if I call this function, then it creates a new GL quadratic object. If I draw GLU sphere, the first kind of parameter is a quadratic object. So this is kind of typical example of object oriented, where operation receives the first parameter as the object. Like in Python, it's called a class instance, and first parameter is self, and in C++ it is this. So GLU sphere, whatever the function we call, first parameter we pass the object. Now it becomes a kind of methods. GLU sphere function without QObject is a user-defined function. If I pass the object as the first parameter, so this becomes method. I mean hypothetical. And the property of quadratic object. So like if someone draws the sphere, so what would be its property? Means the GLU quadratic algorithm, they would decide the vertices. What is the other parameters like okay, what is the primitive, like it will be point or line or it will be polygon. Okay, if we want normals, in case of we want it to lit it kind of lighting, then we want normal. We don't want normal, that is none. We want normal for the flat. So for each primitive there will be only one normal. Or smooth means per vertex, means each vertices will have one normal. So that is a smooth. What is the orientation of normal? It is coming outside, so it is interior, or it is going inside. Okay. And if we want texturing, so these are the kind of, if I want GL begin, GL end in the kind of fixed function pipelining, then we have to specify the primitive name, then we have to specify the normal, we have to specify the texture, and then we have to specify the vertices that is coming through these algorithms. So we'll have a quadratic object is nothing but it's a manager. It manages various quadratic shapes. Each shape is a kind of in a form of user-defined function, where the first parameter, it takes the quadratic object and internally it generates the vertices for the sphere, cylinder, disk, partial disk, and Q object, so whatever the parameter it is taking as the whatever the information it is getting from the Q object is these information. So altogether, normal, texture, and the orientation of the normal, and what is the primitive, all together, and vertices through these functions, then it draws the kind of, so it would call GL begin, GL end, and in between all the vertices and the attributes. So these are the vertices attributes. Now it becomes a quadratic object attribute, and these method provide the vertice. So pretty simple. Now we are talking about drawing quadratic surfaces, and these quadratic surfaces are provided through GLU. GLU is a kind of a top level package which does the quadratic surface, and internally it called GL library. And how it manages, it creates a quadratic object, and someone has to fill the attribute of a quadratic object, and that object filled attribute object will go as a first argument to this algorithm, so which draws the shape, vertices, and through the quadratic object anyway it receives the vertices attributes, and finally it is done. So it will call the GL function. Okay, so what is lab session? So in lab session we'll draw it. Okay, so this is the cylinder. So a cylinder has two surfaces. So both are circle. So if radius of two surfaces, top and bottom, are different, it becomes a cone kind of stuff. And if they are same, then this is cylinder. This is disk, inner radius and outer radius. This is partial disk, inner radius, outer radius, and then start angle and so. This is a sphere, and it is lit with lighting model. Okay, so this is what we'll do. So we'll start. Okay, so directory is empty. So we'll write a simple function, quadric.python, and here first we'll write the skeleton code, then slowly we'll fill it. So from OpenGL GL import everything from OpenGL.glu import everything from OpenGL.glut glut import everything. Okay, and then it is tradition to write the init function. So def init, and here we will set GL clear color, and then we will we will enable something. So what we will enable? So we'll say just GL enable GL depth test. That's it. So this is a kind of a skeleton code. Def display, and here we'll say GL clear color, GL color buffer bit, GL depth buffer bit, GL color buffer bit, GL depth buffer bit. Okay, now we'll move to reshaping. We'll say def reshape, GL view port 00WH, GL matrix mode, GL projection, GL load identity, GLU perspective. So we'll use perspective projection. Means near will be there will be near and far, and near object would appear big. So 40 is the angle, width by height. If width greater than height, else height by width. Okay, so near is 0.5 and far is 10. That's it. So this is typical GLU perspective, and we will use GL matrix mode, GL model view, GL load identity, if name equal to main, glut init, glut init display mode glut. So we'll use single glut RGB, glut depth, glut init window size 500 by 500, glut init window position 100 by 100, glut create a window, and its name would be Quadrics. We'll call init, glut display func display, glut reshape func reshape, glut main loop. Pretty simple. Now we have the code. Okay, so we'll execute it. no one stops us executing it. So I can say python quadric.py and window is there. So we can say C window 500 by 500 window is generated. Okay, so we'll fill it. So we'll create one quadric and then we'll show it, and slowly we'll kind of generate more quadric objects. So that is the idea. Okay, so we are inside the init, and here we'll create. So I'll say start list equal to GL. So we'll use the display list to store the quadrics. So I'll say 1. So start list equal to 0 and global start list, otherwise it would be free variable and it become a local variable if we start writing it like this. So we have to bind it into module namespace. So it is GL gen list 1. So we'll create a q of equal to GLU new quadric. So this is one quadric object and GLU. Now we'll fill the property. So we created the object and now we'll fill its properties, attributes of the object. What are the attribute? GLU quadric draw style. So you want it to be polygon. So this is the q of first parameter GLU fill. GLU quadric normals, q of GLU smooth. Okay, so we want per vertices. It is quite clear. And GLU quadric texture. So we don't want texture. So we'll say GL false and GL. So now we'll create the display list star. So we'll create it start. So it's start at the beginning and we'll say compile. So this is new display list and we'll say GLU sphere. So we'll draw. So we'll call the operation. Okay, so q of, and this is probably slices, and this is so this is radius and this is slices, this is a stack. Now sphere is ready. We can end the list. Now list display list is ready with the start list. Otherwise q of is done. New quadratic equation, style fill smooth. We don't want texture. So normal right now we'll say none, probably because we don't want lighting. So no normal, no texturing, and only this much. Now here in the display, so we'll say GL translate 0, 0, minus 5. So translate first. So I can say GL push matrix and GL pop matrix. So every time it would translate, and now it is kind of a good time to draw it. So we'll say kind of call list. So GL call list, start list. So start list is a free variable. So it is okay, means we are not modifying it. So start list, it would come from here and it's alright. So that's it. So we fill the attribute, like we don't want normal, we don't want texturing, so there is no concept of orientation. We want polygon, point, line, polygon, and we are calling GL sphere. So first parameter we are passing Q option. What we will try. Okay, GLU end list is not there. So GLU new list, GLU end list. GL new list, GL end list. Okay, so nothing. Okay, so probably we have forgotten to flush it. GL flush. Now we'll try. Oh, so it's coming. So this is a sphere, and we can make it kind of lines, line. Okay, so this is kind of wire sphere, wireframe sphere. Okay, there is no rotation, nothing. So this is what we are getting. We can draw others also in this fashion. So this is for one. Okay, so we'll say GL set model as GL smooth right now. Okay, so we'll try for others in similar fashion. 3, 4, 5. So now we will have gen list as 4. So 6YY, whatever we have talked now. Now we have 4. So this is 1 anyway we have drawn, that is sphere. Now we'll say it is fill, and we'll have cylinder. So we'll call it again fill, nothing, and start list plus 1. So we have created 4 display list, and here we'll fill the kind of cylinder attribute. So that is the idea. Cylinder 0.5, 0.3, 1.0, 15 and 5. Okay, so these are its attributes. So I believe this is the base radius for the cylinder. Okay, so for cylinder, the first one is the base radius, top radius, height, slices. So height is 1, and this is the slice and this is the stack. So this is kind of conical. It's not a cone, but it is conical. And now we will kind of draw a line, and again, so it will be +2. And now here we want disk, and so for the disk the property would be 0.25 inner radius, outer radius as 1, and slices would be kind of 20, and ring would be 5. Now we'll draw the partial. Disk, okay, and its properties are like this. Inner is 0, 1, inner outer, slices 20, and 4 is the rings, and start angle is 0 and it is 225. That's it. Then so start list, it is 3. So now we have kind of a display list, four display list we have created, and now we have to show here in the display. So call list start list, okay. So if I call like this, then it will draw 4 overlapping each other. So we can translate somewhere here and there so that they should not overlap. So I can say GL push matrix GL translate, and it would translate in x direction, so somewhere like 0.5, 0, and then GL pop matrix, push matrix, translate, and I would translate it into y direction, and GL pop matrix, GL push matrix, GL pop matrix, and will translate into -0.5. Okay, so hope for the best, and now we can try. Oh, so this is what it is. So we have all the 4, but this is not we are looking kind of. It should be differentiable. So we'll try again. Okay, -0.5 GL push matrix, and we translate it to 0.5, and then we draw the cylinder, we'll translate it to 1, and it is, we translate it to 1, and we'll translate it to -1. Let's hope it would not coincide. Okay, pretty well. Okay, now we have this is cone cylinder, this is sphere, this is disk, and this is partial disk. So this is what we are getting. Okay, so now we'll proceed and we'll add other features. So we have not done anything on lighting. Okay, so we will do lighting. And so before we proceed, so I think we can add lighting, then we'll see keyboard. Okay. Now adding lighting is we have to enable lighting. Pretty simple. So we'll go to init and we'll enable lighting. GL enable GL lighting, GL enable GL light. So light source are many, so light 0 we are enabling. GL enable GL normalize. If we scale, then normalize would be kind of quite helpful. Okay, if we are doing the lighting, then we have to set the various parameter like material color and those kind of things. So we'll set it. So we'll say, okay, so where we can set material color. Okay, probably here we can set, I think before enabling the lighting we can set the material color. So we can say GL material FV, GL front, GL ambient, matte ambient. So ambient we can set directly 0.5, 0.5, 0.5. So you can refer to kind of a lighting tutorial for this. Now we'll set other properties. So GL front specular, and specular would be, so this would be tuple. So we'll set the specular as 1, 1, 1. Then we'll set the shininess. Okay, and shininess is 50. Is 50. Okay, so that's it. So we'll set model ambience. So we'll say GL light model FV, GL light model ambient. And what is the light model ambient? That is 0.5, 0.5, 0.5 and 1. Okay, so we are done setting all the light. So material, ambience, specular and shininess, this is what we have set. And light model, GL light model ambience we are setting 0.5. So this would be calculation, net calculation generating the lighting. Okay, so probably we can take it before, so 4DD and somewhere here. Now, okay, so here we want the lighting, so I'll say, okay, so what would be the GL normal for the lighting? I'll say smooth. So we want for both. For cylinder and sphere, so we'll say smooth, otherwise we don't want. For these two guys we don't. Okay, now if I have set the lighting, then I have to place the lighting. So where we want to place the lighting, So I think when we translate here, I can say GL light FV, GL light 0, GL position, and where we want to position it. So I'll say 0, 0, 1.5 in the positive X direction, Z direction, and this should be kind of directional, not positional lighting. That's it. Or if I say X direction 1 also, 1 and 1Z, then from right side the light would come. Okay, I don't think anything else is required. Okay, we can try. Okay, so lighting has come. It's pretty clear. Okay, we'll disable the lighting when we are drawing these attributes. So we'll say GL disable, GL lighting. If we don't want lighting in while drawing these items, so here we'll say GL enable, GL lighting. Anyway, we have enabled it, and here we'll disable it. So push matrix, before that we'll disable it. So for these two there is no lighting. Okay, it is quite bright now. So now light source we have kept X1 and Z 1.5. So that is on right side light is coming. We can place it on left side if we want. So position, and I'll say -1. So light would come from left side now. That is coming from left side. Okay, so this is what we have finished normal. So if I enable normal and then we call these algorithms, then it calls the GL normal when it calls GL begin. So this is how object attribute we are enabling. Now we'll okay, so we can implement texturing, or probably we'll use one library where we can do some kind of or we can enable texturing. Okay, so this is about so now we will enable texturing. So for enabling the to enable the texturing, we have to generate texture. Okay, I think we can just keep it. Okay, this is without texturing. Now we will write the code again. So if you want texturing, then we have to generate a texture name. So there is another guy called text name, none, text name. Now we will fill the texturing. So text name is GL gen texture, and two texture will create. Okay, now we have two images. So image equal to earth.png and something like pyramid.png. For I in range 2, GL bind texture, GL texture, 2D texture we are creating, text name I, Now this is another object called texture object, and we'll fill its parameters. You can consult a kind of texture the tutorial on texture. So GL text parameter, GL texture 2D, GL texture wrap. SS is in S direction, STR like XYZ, GL repeat. So GL texture 2D wrap as T, GL repeat, GL text parameter 2D texture mag filter, GL nearest, and min filter for minification and magnification. So that is also GL nearest. Now I have img image dot open image I, convert it to RGBA. Now transpose the. So OpenGL is bottom to top, the its coordinates, whereas generally it is top to bottom. So flip top to bottom. Now we'll kind of load the image. So GL texture, GL text image 2D, GL texture 2D, GBA. One is internal format of the image, and another is the format of this texture object what we are loading. Image width, image height 0, GL RGBA, GL unsigned byte. Okay, so finally we are loading the image. So it is of type GL texture 2D and 0 GL RGBA, image width, image height. So that is the height 0 RGBA, internal format and format in the object. GL unsigned byte, its type, and image to byte. So image in byte. So probably we have kind of created two texture text. Now we load the texture. Now we want texturing here, GL call list in first one. So we want lighting, we want texturing. So I think we can isolate GL enable lighting. Okay. GL call list. Okay, so these are the drawings. Push matrix, pop matrix, push matrix, pop matrix, push matrix. Okay, GL enable lighting. Lighting is enabled, so I can say here GL push matrix. Just kind of maintaining the consistency. Now here I'll say I'm interested in texturing, so I can say GL enable GL texture 2D and GL text env. How we want kind of multi-texturing, what would be its native. So GLB env GL texture env mode. So we want GL replace, GL bind texture, GL texture 2D, text name 0. Okay, once it is done, then we can kind of just say GL disable. We don't want texturing now. GL disable GL texture 2D. Okay, so we have done for only sphere. So image would come only in the sphere. So we'll copy the image. So I have image here, image globe, and yellow map.png. I'll say it earth.png. And I'll call pyramid.png. Okay, so I have these many files now, 2 PNG and 1 Python file. So I have used only one PNG. Let's try Python 3. Okay, GL dent texture is not defined. So it should be kind of textures. Let's try again. Image is not defined. From PIL import image. Okay. So we can see kind of everything, but there is no, this is different sphere, but texture. Okay, so we'll see. Okay, so texture we have to enable. So we have to say true. Otherwise for, okay, so this is we are enabling for the cylinder. Now for the sphere we are enabling it to true. Now normal is there. Texture is there. Here normal is there. There is no texture. We try. Oh, it comes. Now we have kind of earth image on a sphere, and whereas others have no image. So we have set texturing on cylinder also. So we'll set texture. We have created 2 textures. So we'll set on the cylinder also. So enable the texturing. So these are the attributes we are enabling, the way we discussed. Normals we have anyway enabled. So texturing we are enabling. Okay, so we'll do same copy paste. So 3YY and paste, and finally we'll disable, and then here I'll use texture 1. We'll try. Okay, so there is a texture on 2. One is pyramid that we can see somehow, and one is earth. So we have talked about all the attributes. So this was our original. Probably we can bring it again. Okay, and we brought the texturing. So now lighting is there and texturing is there. So lighting is disabled when we texture. So that is the default idea. So that we can enable. So for that we have to set property, because texturing is another way of kind of coloring only. So whatever the calculation happens, lighting happens first and then texturing happens. So that is a kind of a problem. So wherever we have set the model, light model, okay, so here we'll set another property, light model color control and GL separate specular color. Okay, so GL light model color control, GL separate specular color. And if I set this, then the specular computation of the lighting will happen post texturing. So there should be effect of lighting. Oh, I mean it's visible. So lighting can be seen. So light is on left side. So we can see the difference. Lighting without lighting and without texturing itself, but with light. So this is how we draw the quadrics. Okay, so means what is guarantee that these shapes like Earth, it would be nice if we really, or it would be nice if we can rotate these objects. I believe there is no harm in that. Okay, so for that we have another module that will take a kind of help from those modules. Okay, so I have a module called OpenGL util. So I'll copy it, and it provides a keyboard activity. So we are interested in keyboard activity. So I'll say quadric here, and here we'll import sys, and I'll say here from OpenGL util. Now we copied, import util C is the library, and we'll create util I of util C. Okay. Now all we are doing for the keyboard support. So we'll set here like different shapes, like light source, sphere, cylinder, disk, partial disk. Okay, so this is shapes, and default shape is light source, and there is transformation map, okay. So we will have a kind of a new function called keyboard. So we'll add here glut keyboard func as function keyboard, and we'll add it here keyboard function def keyboard key xy, where key equal to bytes key, global is transformation, shapes shape, if key equal to byte tab, in that case we change the shapes, whatever current shape is, shapes dot index shape plus 1, shapes dot index shape plus 1, shapes dot index shape plus 1. Okay, so shape we are moving 1, and now we call util I whatever the object we instantiated dot keyboard key dot transformation shape. Okay, if key equal to verbose, then we'll print the current shape and current transformation glut post. That's it. So this is a keyboard function, and it modifies the transformation matrix, and transformative matrix is 1 for each shape. Shape keep increasing if I press tab, and it print the verbose message. That's it. Now we'll go directly to the display, and we'll change the way it is displaying. So that is the final idea. Okay, so now I'll say for L shape in shapes GL push matrix GL translate x if len of x equal to 3, otherwise it is the rotation, else GL rotate F for x in transformation L shape. Okay, so we are iterating the transformation L shape, and for L shape we are doing translation and rotation. If L shape equal to light source, if that is the case, then we enable the lighting. Okay, and we place the lighting at some position. So we'll change the position because we'll do now some funny thing. So I'll make it 4. And let's make it a positional light source. That's it. Okay, and now it's time to move to our favorite L. If L shape equal to sphere, If that is the case, then no need to do push now. So we'll enable it, call list, disable and not required. Okay. If L shape equal to cylinder, again we enable it and no translation is required. Call list, disable it, that's it. And if L shape equal to disk, we disable the lighting and nothing is required, just call it, that's it. And if L shape equal to partial disk, same thing, it will be 3 here, that's it. Okay, now we will will pop the matrix, because globally we have set the matrix. Okay, so we have disabled the light, probably after that we can enable the light. GL enable. Okay, so since light is enabled, probably we don't need enabling the light again, but anyway, it's all right. And we have done push matrix, so we'll do the pop matrix. Okay, so we are done. Now, what is the concept behind adding this library is, what we have done is, we have created various shapes like light source, sphere, cylinder, disk, partial disk, and initial shape is light source. Based upon the keyboard, the focus on the shape would change, and in the display we draw everything. If it is a light source, this is how we draw, and if it is a sphere, this is how we draw. If it is a cylinder, this is how we draw. And now in the keyboard function, based upon the shape, whatever the shape is, if it is tab, which moves change the shape, otherwise we take the transformation on that particular shape. Okay. Okay, there is no harm in showing the code for the. Okay, so we'll see def keyboard, and keyboard it does kind of LR, left, right, and so transformation and rotation. And if it is a small g, then it is grand coordinate, otherwise capital G, it is a local coordinate. So everything is done. So we'll try now Python 3 quadric. If L shape equal to quadric 71. Oh, okay, this is what it is. Now we'll see, we'll press V and we'll see where the focus is. So right now focus is on light source, that we can see. So if I do any transformation, the light source would move. So if I say Y, move along Y direction, light source is moving. Okay, it is pretty clear the light source is moving. coming back to same location. Now if I press tab, if I press V, now sphere is in focus. So if a sphere is in focus, I can rotate the earth. Okay, along x-axis, not, we don't want. Along y-axis, okay, this is what we want. Okay, I can bring it near. Okay, and I can rotate it. Okay, so this is how it is. I believe this is North Pole, and this is Antarctica. This is Antarctica. Okay, so I can rotate the earth, and this is how earth rotates. Okay, so this is America. So this is other side of the earth, and this is full Pacific Ocean. Okay, we tilted. Okay, this is how it is. I mean, we can bring it. Okay, so currently a sphere is in focus, and these are the transformation metrics for the lighting, what we have done. And for this is for a sphere. And now if I press tab and press V, then now cylinder is in focus. So we'll bring the cylinder in front now, and we'll do some rotation. So this is pyramid. Okay. So this is how it is rotating. This is hollow. This is hollow. Okay. If it is rotating like this, probably we have to fix some Z and X, because it got tilted. Okay, it is. Okay, so it is better. So this is pyramid. So I believe it is all right. I can rotate like this. Okay, or on local coordinate I can rotate like this. So I can move to its right direction. It should go away. Now if I press tab, then disk is in focus now. I press tab. Now I can bring it in front. This is disk without any lighting and texturing. I can rotate the disk. This is how it is. Okay. Now if I press tab again, then it is partial disk. Shall bring it in front. This is partial disk. So this is how it is. So I mean, okay, so I have, now I can change the earth. Like I can copy another one, image globe, and kind of convert satellite 5000.jpg to earth.png. It's a very big image. So I'll try again. Oh, so earth is different now. Now I can bring the earth in front. And this is how it is. Okay, I can bring it even front. I can probably change the light. Lighting is too much. Then I can rotate. Okay, so rings are less that we can see. So we can increase the length. So what we have done is, whatever we created the sphere, GL is sphere. So stack, this is a stack, so I can make it kind of 20 and I can make it 25. Let's see if it really draws it. Oh, it comes up. Okay, nice. And I can bring it near, so it is smooth. It is really earth. Okay, so we started diagram from here, black and white. Then we got this. Then we got lighting on the texturing. And finally, we got this.